Hello, dear students. Let us continue this lesson, Mass and Density. Objectives. At the end of this video, students will be able to measure the mass of an object using the pan balance and the digital balance. Measure the mass of a solid object and a liquid. Instructions. Before you start, please read and follow these instructions. Sit in a quiet place. Prepare your stuff. Follow your teacher's instructions. Repeat the video more than once. Ask your teacher for more clarification. The materials that you want to use are your mobile phone or your tab, a calculator, a notebook and a pencil to take some notes, and the physics booklet. You learned from the previous lecture that an object that contains more matter, like the Big Apple, will have the greater mass. Then, as a definition, the mass is the quantity of matter that an object contains. Also, you learned some of the units of masses: milligram, gram, kilogram, and ton. But the SI unit of the mass is kilogram. How can we verify that the mass of the Big Apple is greater than that of the smaller one? It's e-learning time. To verify that the mass of the Big Apple is greater than the smaller one, we have to use these instruments that are called the balance. There are two types of balances: the balance with equal arms, or we can call it the Roberval, that has two equal arms, and the second type is the digital balance that gives a numerical value. It's lab time. Now, we have to indicate the mass of each apple using a balance with equal arms and a digital balance. To indicate the mass of each apple using a balance with equal arms, we have to use these materials: the balance with equal arms and the standard masses. Let's start. First of all, place the Big Apple on one arm of the Roberval balance. Then, to find the mass of this apple, we have to use the standard masses. Use the standard masses to find the mass of the Big Apple. Let's put the 20 grams. Nothing changed. Let's put these two standard masses. Oh, an equilibrium between the two arms is obtained. You have to take into consideration that in order to find the mass of any object, you have to keep the arms of the balance equal, like that shown in this figure. Then what will be the mass of the Big Apple? The mass of the Big Apple is equal to 100 gram plus 50 gram to give 150 gram. Then you have to add the values of the standard masses to get the mass of the Big Apple. Now, let's find the mass of the small apple using the balance with equal arms. First, place the small apple on one of the two arms, like that shown in this figure. We place 100 gram on the second arm. What do you observe? The arms of the balance become equal. Then, the mass of the small apple is equal to 100 gram. Now let's find the mass of each apple using a digital balance. This is the first digital balance. Put the small apple on it. This balance indicates 102.5 grams. Then what will be the mass of the small apple? The mass of the small apple is equal to 102.5 grams. Bring the second digital balance and put the Big Apple on it. This balance indicates 154.5 grams. Then what will be the mass of the Big Apple? The mass of the Big Apple is equal to 154.5 grams. This table summarizes the values that are obtained by measuring the small and the big apples using the digital balance and the balance with equal arms. I want you to compare these values in each case. Look at the values of the mass of the small apple taken by the balance with equal arms and the digital balance. The mass of the small apple using the balance with equal arms is 100 gram, smaller than its mass using the digital balance, that is 102.5 grams. Look at the values of the mass of the big apple taken by the balance with equal arms and the digital balance. The mass of the big apple using the balance with equal arms is 150 grams, smaller than its mass using the digital balance, that is 154.5 grams. Can you indicate which one is the more accurate balance? Of course, it's the digital balance that gives the exact value. Till now, you learned that to indicate the mass of any object, we have to use the balance. In the first balance, the apple is heavier than the orange. And in the second balance, the watermelon weighs 1 kilogram and 550 grams, because if we sum up the masses of these standard masses, they give 1 kilogram and 550 grams. Example: name the instrument used to measure the mass of the lemon. Of course, it is the balance with equal arms, or we can call it the Roberval balance. Number 2, calculate the mass of the lemon. First of all, you have to pay attention that the arms of the balance are equal. Then add the masses that are placed on the second arm, 50 gram plus 20 gram plus 5 grams to give 75 grams. Then the mass of this lemon is equal to 75 grams. This is all about measuring the mass of a solid body that could be by using the digital balance or the balance with equal arms. But what about the mass of the liquid? How can we measure its mass? Of course, we can't put the liquid directly on the balance. Then how? To indicate the mass of a liquid, you have to use these materials: the digital balance, graduated cylinder, and wash bottle. Procedure. First of all, you have to measure the mass of the empty graduated cylinder by using the digital balance. Put it. This balance gives 40.8 grams. Then, the mass of the empty graduated cylinder, that is symbolized by M1, is 40.8 grams. Second step is to pour the liquid inside the graduated cylinder. Then measure the mass of the graduated cylinder with the liquid by using the balance. The balance gives 65.6 grams. Then the mass of the graduated cylinder with the water that is symbolized by M2 is equal to 65.6 grams. Then the values that are obtained are the mass of the empty graduated cylinder M1, that is 40.8 grams, the mass of the graduated cylinder and water, that is M2, 65.6 grams. Then what would be the mass of the water only? It is the difference between these two values. That is, the mass of the liquid is equal to M2 minus M1, 65.6 grams minus 40.8 grams, that gives 24.8 grams. Evaluation time. Look at this figure and then answer these questions. Name the instrument used to measure the mass of the empty beaker. What is the mass of the empty beaker? What does 120 gram represent? Find the mass of the water inside the beaker. Pause the video and start to solve it. Number 1, name the instrument used to measure the mass of the empty beaker. Because it gives a numerical value, then it is a digital balance. Number 2, what is the mass of the empty beaker? This is the empty beaker, and the balance indicates 70 gram. Then the mass of the empty beaker is 70 gram. Number 3. What does 120 grams represent? This balance is measuring a beaker filled with water. So, 120 grams represents the mass of the empty beaker and the mass of the water. Number 4. Find the mass of the water inside the beaker. As we said before, it's the difference between the mass of the empty beaker only and the mass of the empty beaker with the water. And from number 2, we get the mass of the empty beaker, that is 70 grams. And from number 3, we get the mass of the empty beaker and the water. Then the mass of the water only is equal to M2 minus M1, 120 grams minus 70 grams to get 50 grams. It's optional to you to solve these questions. Observe the following figures, then answer the questions. Find the mass of each ball, but pay attention that these balls are identical. How many balls should be put on the arm to balance the scale? Find the mass of each package. Study the lesson well, then try to solve them. I want you to review the previous applications and the evaluation. Underline and memorize the bolded paragraph and copy the answers on your booklet worksheet 4. It's optional to solve the final questions mentioned in this video. This video is prepared by teachers Fatima Noon and Salwa Shabshul, recorded by teacher Zainab Saifuddin, reviewed and supervised by teacher Ghaida Ashraf. Thanks for your attention.